Alright guys, so this is the question we're going to be doing. Two blocks are connected by a string passing over a frictionless pulley. When the blocks are in motion, block A experiences a force of kinetic friction of a magnitude of 5.4 newtons. The mass of MA is 2.3 kilograms and the mass of the second block is 3.5. So first we're going to start off by drawing a couple free body diagrams. So start off by drawing diagrams. FBD. We're going to draw for the first one first. So it's going to be like this. We have the force of tension pulling this way. We have the force of friction pulling this way. That's first FBD. This is the second for the second block. We have force of gravity pulling down, and force of tension holding it up. And we'll draw the system one just for reference. There's tension pulling up. This is force of friction, force of tension. So first we gotta check which way the system is moving first of all. So we gotta see if this is enough to overcome the force of friction. So we can do that by just doing a simple calculation, finding the net force. No, just finding the mass of block B, and if that is bigger than, if that in newtons is bigger than this, that means that the direction of motion is this way. So we're gonna find that out quick. And B equals 3.5 kilograms. Mg equals force of gravity. So the mass here is 3.5 times 9.8. Plug that into our calculator. We get 3.5 times 9.8. That's force of gravity. Force of gravity. What's that? Since force of gravity is more than 5.4 newtons, therefore this is positive, this is positive, this way is negative, this way is negative. So to demonstrate that, it's plus, plus, negative, negative. Alright, keep going with this question. We gotta list our givens. So our givens are, so mass A equals 2.3 kilograms. Mass B equals 3.5 kilograms. The friction force on B equals 5.4 newtons. So required. For part A, we're looking for the acceleration of the total system, so we're looking for that analysis. So for part A, first we gotta find the F net of this block B. So F net of B equals MA. Therefore we can conclude that MA equals force of friction. Sorry, this is block A, sorry. Force of first tension minus force of friction. It's a minus since the direction is the other way of friction. And then we already know mass. We want to find out tension to plug it back into this formula. So we can do this. We can just simply, we can do mass plus force of friction equals force of tension. So after you have that formula, you save that formula, and then we do the net force. This is for B. This is for A. Sorry. A. Okay. Force tension. A right up there. And now we do this formula for the second equation. F net equals MA. So ignore that. And this equals F net equals force of gravity and force of tension, because tension is negative here because it's going up here. So we have that gravity minus, sorry, if it plugs in MA plus 5.4, so F net also, F net 5.4 is the friction force, or you can just say 5.4, yeah. F net, this is the finished formula. MA equals this MA is obviously A and the same as B. After we do the whole system, and then we just add these two formulas together. We see what we have here first. So we would have for block B, it would be block B, so it's 3.5 A equals gravity, which is mg. The gravity will be for this block over here, block this, so it'll be 3.5 times 9.8 minus mass of the second one times that, so 2.8 A. Force friction is negative 5.4. So we equate this. Also, you would bring this to the side, so it'll be 5.8 A. And if we add this all together, we'll get a total of 3.5 times 9 point this, subtract 5.4, so subtract 5.4, 28.9. Acceleration equals, therefore acceleration is divided by 5.8. Equals 5. We rounded it to the nearest sig fig, which is we here see is 2, so we just rounded. Everything I did was okay, and it should be 2, so it should be 2 meters per second squared. And that's the answer for part 8. Okay, now moving on to part B. I have another piece of paper over here. So we have to, this is part B, so they want us to find the tension in the string, so the tension here. So say our givings again. Mass A equals 2.3 kilograms, mass B equals 3.5 kilograms. Force friction equals required. Looking for the F on mass A, so it's A. Analysis. And we also have the accelerations, right? Sure. Okay. Analysis. So we know that F net equals M8. And we take the mass of the first block, the mass of block A, so it's 2.8 times 5.0 equals, if you do that calculation quick, sorry, 2.3 times 5, 11.5 equals F net. Solution. We can take F net and do force of tension minus force of friction, that, and then we can take the net force plus tension equals, no, plus friction, sorry, it's friction, equals force of tension. Solution. So Ft equals Ma plus force friction, so Ft equals plus 2.4 newtons, sorry, equals 11.5 plus 5.4 which equals 16.9 newtons force tension. And say that force tension equals 17 newtons. So there you go, guys. Force tension for answer B, it's 17 newtons, and for part A of the question, it's 5.0 meters per second squared. Thank you.